Hello everyone. Recently in the Reals approximation community, there's been an exciting development of a new representation called Posit, which is being used in applications like weather simulation with great accuracy. Additionally in Posit, sigmoid function can be approximated using a few logical operations, which is exciting for the ML community. But if you naively build programs using Posit, your program might experience a lot of numerical errors. Then where do you even start debugging your program? This is exactly why we've built a tool called Posit Debug just for you. With Posit Debug, you can debug and identify numerical errors even for large programs. Also, all the cool techniques used in Posit Debug can be applied in debugging floating point programs too. So we built Episanitizer that can debug large floating point applications as well. If you want to learn more about Posit Debug and Episanitizer, please come to Sangeeta's talk at 2:40 p.m. on Wednesday, June 17th. Thank you very much.
Data races are a kind of shared memory error that are a problem both in theory and in practice. They cause significant harm and costs. And don't just take our word for it. Sarita Adve and Hans Bohm have both called data races evil in the titles of their papers. So the state of the art is that tools like Fast Track and Intel Inspector and Google's Thread Sanitizer can find many data races by observing program executions with low enough overhead for use in testing time. Prior work has shown, though, that by observing program executions, more data races can actually be found by applying so-called predictive race detection analysis. However, the overhead is significantly higher. Our work introduces insights and algorithms in the form of the SmartTrack algorithm, which finds these same predictive races, but has nearly the same performance as the FastTrack algorithm. To find out more, come to our talk on the first day of the conference.
Rust is an increasingly popular programming language. It has been adopted to build many safety-critical software. There have been a lot of debates on whether Rust is really safe and whether programmers should switch to Rust, and there's no clear conclusion. No one really knows how Rust is used and how safe it is in the real world. We conducted the first empirical study on the real-world Rust safety practice and issues to answer these questions. We manually inspected hundreds of unsafe code usages, memory safety issues, and thread safety issues from more than 10 open-source Rust software. We answered several important questions in Rust programming and have many interesting findings, and we also made concrete suggestions to the programmers, language designers, and tool designers. If you want to know more, come to our talk.